After black hole, we would like to talk to you a bit about the Big Bang. Whenever something is said about Big Bang, it is said that it is all of this universe started at Big Bang. And this is the classic picture that you come across. You put in Google Images, Big Bang, this is what you will get. What I say is there is an error in this picture. And we will see what the error is. Basically, the Big Bang is, this is the contemporary universe as of now. So Hubble observed the night sky, and he found that all these galaxies are moving away from each other because they were all redshifted. So he inferred that if they are moving away from each other, there should have been a time in the past when all these masses, galaxies of all these masses, would be starting from a single point, and that point was known as Big Bang, which is shown here. And this is 13.8 billion years before. So let us try and understand that to find this error, we need to analyze what is a mass, what is energy. So let us talk about it a bit. Pure energy. Energy, I don't mean to say electricity, magnetic force, heat. These are all energy which are based on mass. I'm talking about pure energy. Pure energy does not interact with mass. It just flows through you. You cannot measure pure energy because it doesn't leave any fingerprints. You can't weigh it, you can't find its temperature, there is nothing. Pure energy doesn't have these parameters. All we know about pure energy is it moves from a higher density to a lower density, that is it. Whereas in case of mass, it can be detected. It has a size, shape, weight, volume. You can touch it, you can feel it, you can see it moving, it can cause damage, it can alter its vicinity. So we know mass, we can detect it. It's not just when it is near you that you can hold it. Even if it is billions of light years away from you, you can still see or detect that mass. How? Because of the fingerprint that it leaves. What are those fingerprints? These fingerprints are electromagnetic waves, EMWs. Based on the state of the mass that it is in, it emits these waves. These waves are, let's say, the most unexcited form of mass, the black body, generates radio waves. Whichever mass that you have has to generate radio waves. You excite it a bit more, then you have microwaves. Excite it a little more, you will have infrared waves. So after the infrared, you have red, and then you have the visible light spectrum, which is basically red, orange, yellow, green, blue, indigo, and violet. Excite it a little more. Beyond violet, you have ultraviolet, X-rays, and gamma rays. These are the ones which are more dangerous. But generally, what you see is all these types of waves are basically fingerprint. And the visible light is only one part of that fingerprint. So we can say that light is just another form of mass expressing itself. In the sense, if there is light, there is somewhere mass. Or if there is radio wave, there is mass. So if there is light, there is mass. If there is no mass, there cannot be any light. So this is obvious in nature. So Big Bang is a state of pure energy. I'll explain you why we are talking about Big Bang being pure, state of pure energy. When I say it's state of pure energy, there is no mass when it all started. The Big Bang, there was no mass. But how do we prove that there was no mass? Let us assume, for the sake of argument, that Big Bang was all mass. It was not pure energy. If it was mass, the prevailing temperature and the pressure, imagine the mass of the universe is concentrated in one single point. The pressure and the temperature would be astronomical, infinite pressure and infinite temperature. If mass is existing at that state, the Big Bang would then be the best forger of elements, of the universe. We have this periodic table, the elements. We know for a fact that it starts with hydrogen, helium, and it keeps on adding on, having complex elements. These complex elements are said to be forged in the heart of the masses, the mass of the star. These stars, they started with hydrogen and helium. And then when they met their end of life, they went supernova or whatever. And then new, bigger mass of stars came up. And then higher elements of the periodic table were forged inside those bigger masses. So, one thing that we should know is that astronomers consider hydrogen and helium as the only two gases. The rest of them are all metals, considered as metals. Even oxygen, the gas that we breathe, nitrogen, they are all called as metals. Just the way you consider copper or gold, everything is metal. Only non-metal element is hydrogen and helium for astronomers. So if the Big Bang was mass, the temperature and pressure which is available for the mass to produce more complex elements would be the ideal condition. Then you would possibly have all the elements of the periodic table at the time of the beginning of the universe, possibly even beyond the periodic table, because periodic table is something which is always evolving. Now, what does that mean? So when you look back into towards the Big Bang, near the Big Bang, you should be able to detect all these metallic atoms, oxygen, gold, iron. You don't. What you see is only hydrogen and helium. This is what proves that Big Bang was all pure energy. Mass came far, far later. So when we say Big Bang is pure energy, see what happens to this picture. Big Bang is pure energy. Pure energy means there was no mass. When there is no mass, how can there be light? There was no light at the beginning. The pictorial representation that you see here is the error that I was talking to you about. Maybe it is shown because it looks good. It's soft on the eyes, that there was an explosion. Of course, the explosion there, but it was infinite energy concentrated in a particular an infinitesimally small point, and that dense energy, by the very nature of energy, it dissipates from higher density to lower density. It escaped.